working with Docker. You don't need to recap, do we?
We need.
Oh, that's quite a long lecture then. I think I'll just point you to the documentation. I did make some. Where's that? Oh, okay. It's up here now. Yeah, so I wanted us to talk about Docker files. So as a way of recap, and maybe if you go to day 2, what we were doing in the other class, you see sort of the lectures that we went through, but I'm just going to do a quick recap. So containers, because we covered that with some of you last year. And the idea is just to take advantage of containerizations, because there are a couple of advantages that containers do. They are very portable. They allow you to make very reproducible workflows, particularly if you working with workflow managers, and they're also really portable. So sometimes as a bioinformatician, you'll have a lot of trouble installing, setting up files, or rather setting up builds, and you can get along with Coda, for example, trying to build virtual environments. And what these virtual environments allow us to do is to isolate concerns, isolate particular analysis, and within them include all the builds, and be very specific about particular projects. Okay, so if you're on a Windows machine or a Mac OS machine or a Linux machine, pretty much these containers allow you to roll out multiple images and have very specific analysis setups, and very portable analysis setups. And if you're working with a workflow manager, it's even easier, and you can take an entire workflow and put it in a Docker image and roll that out, and makes for very reproducible workflows. Okay, so so if you remember, we got Docker, which is this engine that sits on top of an operating system, and allows us to import images, which are particular configurations, if you like, and then it'll allow you to run as many containers from a single image as you like. Okay, and all that is managed by the Docker process, and Docker is also sort of the company, and you got this huge registry repository where you can download or pull images. So if you want to run an image, if you want to get an image, you can just run Docker pull, give the name of the registry. By default, Docker Hub contains all this registry, and just by running Docker pull, the image, the name of the image that you want, you can have that image running locally in your environment, as I'll probably show in the practicals. But how do you create them? How do you set up? It turns out that it's relatively easy in the sense that you got a limited set of commands that are quite easy to understand, and you get a configuration file that is called a Docker file inside a repository, inside a directory, and using these commands, you can then build your images. And often you will build an image from an existing image. It's just the easiest way to do it. So you see this command from, which will list the image to inherit from. So let's say I want to roll out a container that is based on Ubuntu or Alpine or CentOS or whatever. I'll simply say from Ubuntu, and I can, as I'll show you shortly, maybe at the during the practice, you can be very specific about the build that you want. You may only have software that works on Ubuntu 16, 04 or 1804 or 2204 long-term release, or Alpine or whatever it is that you want to roll out. Run will execute a shell command. We know that docker run, docker do that, and within the containers, run will execute a command that you want to be available and to be executed in the container. Copy will copy files from your local storage onto the container. As I said, and as we saw last time, you probably want, you can copy files from your file system and make them available on the Docker image. Okay, so you may have particular configurations to make that container easy to use, easy to run, and therefore chances are that you want to copy those files. They will be hosted within a directory where your sort of Docker file, but it could be anywhere actually, and you can import it. And then you can set an entry point, which is a keyword that sets out a command that once this container is launched, that's the command that I want immediately run when I call that container. And working directory will set the working directory for your build script. Okay. So this is an illustration of what I just said. So you got, you're starting to build an Ubuntu image. This will be your Docker file, and you're saying from Ubuntu. I'm not specifying the build, so it'll take that as the base image, and it will execute this command: apt-get update install, and it's going to build or install, or if you're familiar with Linux, Build Essential will put or install tools that are necessary to make installs, okay? And also it's going to install the libSSL that is also quite critical if you want to run software installs, okay? And that can be essential, and if you just run that, you're going to create an image, an Ubuntu image that has that setup, okay? So as I said, if I want to build that image, then I simply call the Docker build, and I give it my tag. In this case, I call it my image, and I'm assuming that I'm within my directory where I want to create my image, or where my Docker file is. It'll be more easy when we run the practicals. And therefore, you should always specify a tag using the T flag and the directory containing your Docker file. So, for example, in here, there's a directory, dot meaning current directory, that has my Docker file, which is just a file named Docker file. Okay, and the Docker build command will execute, and it's going to build that image based on that Docker file. Okay. So I've got a quick exercise here, which is meant to sort of synthesize what we just said, where one of the tools that we're so familiar with in bioinformatics is SAMtools. All right, and what we want to do is do a Docker build, create an image that runs SAMtools or has SAMtools. Okay. So you're going to ensure that it's called my SAMtools for obvious reasons. There may be other images already with SAMtools installed. So you can call it anything. Just make sure it's sort of a unique tag. And then you'll need to set the entry point, okay? So that when you launch that image, you actually running SAMtools, okay? So that once you test it by running this script and giving it sort of an alignment file, you can you can execute that SAMtools command. Um, so when you're working with the Docker files, you can imagine that you're creating these images, you're creating these containers, and you need to be careful about only working with the Docker images that contain only the necessary tools. It doesn't make sense for you, for example, to roll out an Ubuntu image that has MySQL, Postgres, other build tools. If they're not going to be used in the container, it's just going to make that image unnecessarily big. Okay, so and when you call certain tools, so for example, you're working with Ubuntu and you're doing sudo update, you sometimes inherently run commands that will install other things that they're only necessary either to build your tool, and beyond that, they are no longer necessary. So we don't want to keep those files around in our Docker image, so we want to remove them. Okay, so you want to remove these tables. Once you do it, you want to clean your package list once they are downloaded, because we don't need them. So the next thing was an exercise where we're going to create a Docker image for Minimap 2, for example. And this is sort of the summary of what I've just said, and quite easy, just mastering this command. That's all you need to do to create your Docker images, right? So again, from you're going to specify your parent image, you can set up your working directory, you can run and install applications with the run keyword, copy for copying files, and if sometimes you might want to copy files or directories that are on the web, rather than use copy, we're going to use add. And the entry point is going to allow us to exercise or to execute a particular command. And if I have arguments for entry point, I'll specify them using the CMD keyword, and expose will define which port through which the container which accesses the container application. So a little bit interesting, because often Docker containers can be applications by themselves, okay? And often you want to run it, and you can run that image in the background, okay? And therefore, you can set a particular port to forward a request to the host machine, okay? So for example, I may be running a web application in my Docker file, and I compile it, and it's all set up. And then I want to run that off a web server, okay? So I'm gonna set it up, make sure that it runs, and then forward the port to localhost or to whatever other domain, and I can specify how that is set up. And that adds a lot of application, particularly with websites. A lot of them run off Docker containers, and it turns out to be really, really secure way, because in the Docker image, somebody will not necessarily have, or it becomes a bit difficult to access the host resources. Okay. So for those who are familiar with web hosting, when you get your website, it's running off a particular server and machine. You're going to expose this website, web services, or web resources in the actual folders in your server, and somebody can find a way to get around it. Okay, but if they're running off a Docker image on a virtual environment or a virtual server, it's just the best thing, because the virtual environment or the virtual server and the Docker file are very separate. So again, it becomes relatively secure, and a lot of services actually run off Docker images. And also, in the event that that thing doesn't work, you can just delete the entire thing. It doesn't matter. Okay, and set it up afresh. So again, just once you get your image, it will be compiled. It's within your home environment. And if you're within Docker, your local Docker instance will import your image, and then you can call it using Docker run, as it were. But sometimes you may want to, I said Docker run, that should be Docker hub. you may want to export that and upload that image to Docker Hub. Okay, so the way we are going to do is that we're going to build our image, give it our tag that includes our username, and this is the tag for my tool, and then that image is available on the Docker registry, and somebody can pull that image. Okay, so if I was here and I had a particular application and here stack is in Malawi, it's like, how do you make this installation? And I it's a lot. Then it's working on my machine. I can just set it up and send him the Docker image and tell him download it, and you can get this application running. Also, it turns out that Docker can allow you to actually save your image locally. So I work quite closely with John and Arnold. I may compile a Docker image in my home directory and just send them the tarball, and they can import it in their Docker environment using the Docker load, and then that is now available within the environment. And then by doing Docker run and giving the relevant flags, they'll be able to access their repositories. So that's what I wanted to talk about. So what I'm just gonna do is give you a hint of what I was referring to. So this is a Docker file for Minimap. I was going through the tutorial, so maybe this already is giving you a hint of what you're supposed to do in that particular exercise. But I got a more elaborate one. So let's just do it. So I got a directory that I called Docker share here from yesterday. We got a couple of things in it. ls. So technically, I got two images. I got my SAM tools, the example that I was showing you. Let's assume that I want to create a new Docker file. So I'm just going to go through the steps that you can use to replicate that. So what I'm going to do here is that I'm just going to make a new directory. Okay. So I want to create a Docker image. Over here, so let me see if I can get another terminal. Okay, so this could be, your home directory, whatever that it is that you want to make your image. And what I'm going to do is that I'm just going to create a Docker image, maybe called, I have my SAM tools there, so I'm just going to either call it KWTLP SAM tools for whatever reasons. Okay, it could be anything, lack of better name. Okay, so the first thing I do is I'm going to create that directory. Okay, and once I create that directory, I want to create a file in it. You can use your favorite editor, and that file will be my Docker file, just like that. Okay, I use Vim, so you can use Nano, you can use whatever editor that you fancy. And the first thing I'm going to do is that I'm going to base this Docker image on Ubuntu. It can be based on anything really. So what I'm going to do is that I'm going to type the keyword from Ubuntu, and that's sufficient by itself. But I may want a particular distribution of Ubuntu. Okay. In this case, I may want the more stable version. I think Ubuntu 22.04. So I've now specified the distribution of Ubuntu. You can imagine that you can go backwards to 16 or whatever it is. I could also base this on Alpine. I could base it on CentOS or whatever. Okay. And the next thing I want to do is that I know that Ubuntu, it's easy to install some tools using sudo yum update or apt-get. So what I'm going to do is I'm going to run a command which is apt-get update. Okay, so what I'm saying is, within this directory, I want sort of the more recent updated, and then I'm gonna give it the -y flag, and I can run another command here, which is apt get auto remove, so that whatever it is that I've created auto gets removed, and I can run another command. Okay. The sad thing is that the more run commands I do, the more layers I create within my image unnecessarily. Okay, so it's usually not recommended. It may also turn out that this command here wants to cache some files, and that's usually not what you want, although you can do that. So we know that we can run all these commands in a shell all together. So if I just do that, okay, I can run those two commands together, right? So for ease of legibility, I'll do that, okay? I'll just do that, a tab, so that it's legible. And once I do that, I concatenate to the next command, which is now apt-get install some tools. Right, and I mean I could stop there. I got my apt-get, and it's going to install my SAM tools. But remember what I said about removing unnecessary things that may have happened when we are running the install. I'm gonna run an rm -rf and clear the lib the apt directory, because we don't need it. Okay, so I'm just gonna ensure that this is all cleaned. Yeah, and that's it, right? But I might want to specify an entry point so that when I execute this Docker file, Docker image, I'm going to run some tools directly. Okay, so the way to do it is to run entry point keyword. Okay, so our entry point is some tools. Yeah, it will be installed already, so that's how we specify it. And now we've completed our Docker image, and I can save that. And take note of the directory, which I'm going to use the sort of the same directory as my tag. Okay, because you need to have a tag for this image. Okay. So what we're going to do then is to we've saved that file, so I can quit, and I can now use Docker build. Okay. Okay, so we're gonna give it a tag, which in this case was kwtrp. I'm just gonna give it the same name because it just makes things easy. It could be anything really. So that's my tag, and my target directory, because I'm within the sort of Docker share folder, will simply be this is where I have my Docker file. Okay. So just by doing that, unknown instruction entry. Okay, I think I got a typo here. It was supposed to be entry point, and I said entry, sorry. I didn't complete this entry point. Okay, I think we should be good to go now. I can execute my build. Okay, and Docker will create my image. Okay, take a bit of time as it's trying to create that image using just those simple lines. Okay, and now I'll have a SumTools image. Okay, so you can imagine that you're running an analysis, you are only using these specific commands, and therefore you're going to create an image that just contains those specific tools for that particular analysis. You're going to be basing it on a particular distribution, and therefore it becomes really reproducible. Okay, and you can pass that to your collaborator. You can publish that on your GitHub and say, if you want to replicate our analysis, this is the image that contains our analysis. Okay, and what people do actually is that they create entire repositories. You can upload data, and if you go on to the documentation, it'll show you a little bit about what you can do. Okay, so now I got my image here, and if I do this, we're gonna do KWTRP. So if you recall, in Docker, if you want to run an image, okay, we call the Docker run. I for interactive, and we are requesting for a TTY, and RM. I'm saying that once I exit this image, kindly don't keep it hanging, so to speak. Yeah, I don't want multiple instances of it on it. Okay, so if I run it, see what happens. SumTools runs. Okay, so technically I can run this image and give arguments right in this directory to run that particular tool. Okay. So use cases, you may have a tool only that is can only be installed in a particular distro or within a particular setup. Okay, and you want it to be reproducible. You want to share it, so that is one, and you can have multiple such entries. Okay, if you don't specify an entry point, what tends to happen is that you're going to default to a shell. That's what Docker does. But it's always nice to give an entry point, but it's not. It's not important. Okay, and I can bind a particular volume of my drive, just so that I can access this directory. Okay. And if you want to know how many images you've been running on Docker, or active images, you can see that when I run Docker PS, although I just run that image, there's nothing because I specified the RM command, meaning do a cleanup. But if I want to really see what's been running, I can see that I got another Docker image that was exited a couple of hours ago. Which is an Alpine that we were using in the other course. Okay, so that's how you do it. And I'm gonna simply copy a few tutorials onto the Google Drive, and then outline the steps that we need to run so as to replicate this. I think you get best practice by executing this. One of the exercises I had was to rerun that. You can think about any tool that you might want to create a container for. You could throw that with BAM tools. You could do that with more complicated things. You could try, and rather than install this using YAM update, which means that this version of SAMTools that you're going to get is the apt-get version of SAMTools. And that may not necessarily coincide with the most recent version of SAMTools, which is here. Okay, so this is the more recent version. And if you really want to install SAMTools, this is Minimap too. Sorry, yeah, we could try and do Minimap, but we could do SAMTools as well. I don't know whether Hengli still keeps SAMTools, or that went to yeah, he keeps BWA, but I think SAMTools went to Sangha, so still his tool. Okay, so if you want to install the greatest, and Hengli's tools are really easy to install. I don't know whether you have read about his principles of tooling. There is just awesome, honestly. So every repository is self-contained, and often all it takes is to clone the repository and just run a make file. That's it. Okay. So in our build, you can actually download this. You can, I'm not meant to tell you everything. I just point to the right direction and see how to actually create these tools, how you can import this source code using just similar tools that I've shown you, and compile the most recent particular tag, and then you can tag it based on the GitHub tag that or commit, the most recent commit, and you'll have your tool running. Okay. So yeah, so in a nutshell, that's how you create your Docker image. If I want to share this, I just talk to you through Docker save, right? And if I call help for save, I think it should pull out what is required for saving a Docker image. Okay, so I can save that locally as a tarball, and I can share that with a colleague or with anyone that I can have access to the tarball, and then they can then import it in their working Docker registry, and the image will be available for development. Yeah, so I'll just copy a couple of the tutorials on the Google Doc, and then I think we can spend the afternoon creating these images and experimenting with them. And the other thing, I think you can always edit your Docker file wherever you really want to edit it. Okay. Let's see what happens if I remove this entry point. Okay, so just removed it. I'm just gonna save it, and then I'll just run my Docker build. Okay, it's worked. But then if I execute my Docker, run it, the image is there. It drops me to by default it drops me to a shell. Okay, and can I call SAMTools here? Yeah, SAMTools is available. Okay, so I'm executing SAMTools within the container. Okay, and you can see that I can install SAMTools, I can install BAM, I can install whatever it is within the container, and I can run this and bind a particular volume for this container. Okay, and work through. So for example, if I have multiple tools that I want to install or make a particular build to work with, I may not necessarily have a specific entry point. Yeah, I may want to just default to the shell. Okay, and then you can execute a particular command with that tool. So and so if I call exit, and if I do docker ps, you see I don't have any darkling images because of the way I ran it using this flag here. If I remove that, then that image will still be running in the background. Okay, so because I didn't specify my entry point, simply by running the image and calling the particular tool that I know is already installed, I can execute some tools on that image, okay, as a command. Okay, and I can share that with you. I can share with whoever I want, and I can publish that image on Docker Hub, which is super awesome. Okay, right. So yeah, that's all I got to say about building images. Quite straightforward. I'll post a couple of tutorials, advanced. There are best practices that you can go through, and it's recommended. But you can see how powerful this becomes. Yeah. All right. We can go back to the lab. Yeah. Yes, please.
Yeah, sure.
Yeah.
The idea of having layers in a document.
Mm-hmm.
Docker do as we created stored these layers
No. The concept is separate.
separate.
Layers is all about what you are creating within your Docker image.
Okay.
There's a lot more documentation that I'll point out on what exactly are layers. I just don't want to go into that. Yeah.
That's why.
But essentially, containers are supposed to be lightweight. Okay, so by executing some of those commands individually, then you are exposing yourself to, they're gonna create these files. So if you're familiar with like build tools and directories and so on, installation of a package is much more than that. There are all these temporary files that need to be stored. You've not specified where they should be, so most likely your build will fail. And for this, the best practice is to do what I just showed you to do. So it's a little bit, so you need to be familiar with the Linux, Unix, what exactly you are doing. So this is just a means to an end. I can't teach you exactly, and building an Alpine container may be slightly different because you don't have apt-get, or I may just, the right way is to just build it yourself, so rather than depend on a package manager like apt-get or apt, is actually to go download it, clone the repo internally in the container, run the build, clean up, leave only the executable, exit, and either set an entry point or leave it as it were.
Okay. So these layers, they usually sort of separate images.
No, I think we need to learn what the layers are. Yeah, first.
I have a challenge with that because do that similarity pool, you always get these layers.
Yeah.
I wonder what they are.
Yeah, I think, yeah. I'll not get into that.
Yes, George, I'm wondering, is there a limit to the number of images you can upload to the registry?
Good one. I don't know. I don't know whether you pay beyond a certain, or if your images are. I think if your images are private, you may have to pay. Also, if you're an organization, I think there may be a limit, but I don't know whether if you're using open source tools. I don't know. Maybe something to check with the Docker Hub. Okay, yeah, we can check that online, whether they are in a, or whether they are what the pricing comprises of. Yeah, but I know like private organizations that wants to host Docker images probably would have to pay. Yeah, and I mean that's maybe how the company makes money. At the end of the day, somebody gets paid to maintain this technology. Yeah. We say open source free, as in beer, free beer. and that's a good open source. All right. Yeah, we can dig in a little bit into layers.